this video, we discuss how to graph, recognize, and write equations of circles. Let's get started. To begin, consider your favorite circle. Remember that to be a circle means that every point along the circle is equidistant, the same distance away from the center. That distance was known as our radius. So if we're trying to find the equation describing this kind of circle, we need to first pinpoint where our center is, the point from which everything radiates, right? So we name that point HK out of convention. So if your center is HK, then you pick a point on the circle, any point you want. In this picture here, you can see that we've picked the point P, and we're just using the generic X and Y coordinate to describe its location. Okay, so how do you describe that distance between the center HK and the point P, a generic point, on the circle's graph? Well, if you remember the distance between 2 points, we had our distance formula. x2 minus x1 got squared. It got added to y2 minus y1 squared, and then we took the square root. Remember, that was derived from the Pythagorean theorem. Well, if that's the distance between your center and any point on the circle, which is your radius, then we can say that's equal to your radius. But the square root looks a little tacky, so what's a way we could get rid of it? Well, we could take both sides and raise them to the second power, and that's what we've done at the bottom of that box. We have x minus h squared plus y minus k squared equals r squared. In other words, that's your a squared plus b squared equals c squared for a Pythagorean theorem. So that's what we call our standard form of a circle. Anytime you have both x being squared, y being squared, the terms are added together and they're equal to some constant, that's describing a circle in standard form, where the HK are telling you you've shifted your center from the origin to a certain location HK, and the R is going to tell you the radius of your circle. So for example, suppose you have a circle whose center is at the origin, so its center is 0, 0. Well, that would be my H as 0 and my K as 0. In that situation, if the radius was 2, can you write out what the equation in standard form would be for this circle? Go ahead, pause the video, try it yourself. Did you get x minus 0 squared plus y minus 0 squared equals 2 squared? If so, you're correct. But that looks a little tacky, right? X minus 0, that's just x. Y minus 0, that's just y. And 2 squared, well, that's just really 4. So another way to really write this would have been, let me just clean that up for you. Oops, there's my eraser. Grab it, and there we go. What would the other way of writing this be? Can you see what it would be on your own? That's right, it would have been just x squared plus y squared is equal to 4. Well done. So that is in fact the center, so the circle whose center is the origin and whose radius is 2. Now a lot of students get confused when they see the 4 there, they think the radius is 4, but remember that's the radius being squared. So really whatever number we see there, that constant is r squared. So to find r, you square root it. Now keep in mind, this is called the standard form of a circle. Circles could also be written in what we call general form by simply getting all terms on one side, and if there was any foiling that needed to be done, doing that and combining any like terms. So we'll talk more about general form as we move forward. Let's head over to our next slide. In this slide, we have the example that we're given a circle whose radius is 7 and whose center is at -5, -2. They're asking us to write the equation of this circle in standard form. So again, you can look back at your previous slide and see if you can do this yourself and come back after pausing the video. So to begin with, I could show on the picture what's going on here, right? -5, -2 is the location of my center. So -5, that's 5 units to the left, and then down 2 units. So this would be the location of my center at -5, -2. From that central point, all other points radiate 7 units in each direction because r is my radius. So I could simply go ahead and do a sketch of this circle by going up 7 units from the center. So 1, 2, 3, 4, 5, 6, 7. So the y value there is at 5 when the x value was at -5, right? I could also go 7 units to the left of the x value -5. So that would bring me to -12. 1, 2, 3, 4, 5, 6, 7, somewhere out yonder. And I could go 7 units to the right of the x value -5. That would bring me to an x value of 2. So that would be around, whoops, right there. Oops, let's grab the pen better. So 1, 2, 3, 4, 5, 6, 7. There we go. And then I could also go 7 units down from the y value of -2, which would bring me to the y value -9. So 1, 2, 3, 4, 5, 6, 7 at -9. And now I can simply connect the dots in a circular manner and get a sketch. Of course, this would be much better if I had a compass and a protractor to draw a better sketch of this circle. But the idea is to be a circle, as you've learned since you were probably younger, that means that you're talking about all points which are equidistant, not a perfect circle by any means, but all points which are equidistant from a central location. And that equal distance is called your radius. Okay, so since we have a sketch here, can we describe the actual equation for any point along that trajectory, that circular pathway? Well, yeah, we can, because we recognize that a circle in standard form has an equation of x minus h. H is the x value of your center of your circle, plus y minus k. K is the y value of the center of your circle, equals r squared, where r is your radius. So I always encourage my students to write out their formula that describes the type of trajectory you're discussing. Then simply fit in the pieces that you have. This one's kind of obvious, right? If the center is at -5, -2, replacing h with -5 means we have the opposite of h. So the opposite of -5, x minus a -5 is really x plus 5. So x plus 5 squared. Then y minus our k value, but our k value is a -2. So the opposite of -2 is +2. So we have y plus 2 squared. Now our radius is 7, but we're supposed to take r and square it. So 7 squared is 49. So this would be x plus 5 squared plus y plus 2 squared equals 49. This would be our equation of the circle in standard form. Again, it's fitting nicely into our pattern, but we could also have foiled both sides, x plus 5 times x plus 5. You'd get x squared plus 10x plus 25. You could FOIL y plus 2 squared and get y squared plus 4y plus 4. And then you can move 49 to the other side by subtraction and combine those constants, and you'd have general form. Not very helpful for graphing, but you will have circles in that form. So we'll be talking more about those forms of circles in just a few minutes. So again, our equation there in standard form is in the orange there. All right, let's see if you can try another one in the next slide here. A little bit harder. It says, could you write the equation in standard form for this circle? This time, they don't give you the radius and the center. Those are the obvious questions, right? This time, they tell you that you have 2 endpoints on the diameter of your circle. Think about what that means again. Diameter is the line segment that cuts the circle in half, right? So it's actually double the length of your radius, and it goes through the center of the circle. If it didn't go through the center, if it just connected any 2 points in the circle, that would just be called a chord. But this is a diameter, so it's going through the center. So let's take a look at what this means on our graph here. 4, 3 is one of our endpoints on the diameter. So let's grab a color. 1, 2, oops, wrong pen here. 1, 2, 3, and 4, and then up 3 units. So 4, 3. That's one of our endpoints on the diameter of the circle. Get a better color for you to see that. There you go. So that's one of our endpoints on the diameter of the circle. Another endpoint they're giving us is 0, 1. So 0 and then up 1 unit, 0, 1. Now again, they're telling us that these are endpoints on the diameter of the circle, meaning that if we were to connect the dots with a line segment, that has a certain length, and that length would be our diameter's length. But what would be the point right in the middle if this is truly the diameter that cuts the circle in two? Wouldn't it be your center? So your center should be somewhere in here, but what is your center? It's the midpoint of these two locations. So to get our center, we have to remember what we've studied in our previous videos, which was how to get the midpoint of 2 points. Remember how we did that? See if you can pause the video and write it down yourself. Did you get the average of the x values, so x1 plus x2 cut in half, and the average of the y values, so y1 plus y2 cut in half? In other words, when you add your x values together and cut it in half, you get 4 plus 0, which is 4, cut in half. In other words, the middle x value, the average x value of these 2 points, is 4 divided by 2, which is just 2. Hey, that's making sense in my picture. What about the average y value between these 2 points to get our center here? Well, adding our y values together, that's 3 plus 1 cut in half. Again, that's 4 divided by 2, which is 2. Hey, that's also making sense. That is, in fact, our center of the circle, which is the midpoint of the diameter's line segment. So now that I have my center of my circle, which is called HK, I can begin fitting that into my equation. Remember the equation for a circle? Can you write it down yourself? X minus h, good, squared, plus y minus k squared equals my My radius squared. So right now, what do we have? Which components of this equation do we have already? That's right, we have hk. So let's replace h. Oops, I meant my eraser there. Let's replace h and let's replace k with the appropriate numbers we've just found. H was, that's right, 2. K was 2. But notice in the equation, it's always the opposite of h and the opposite of k. So that's why we keep minus 2 and minus 2 for next to the y as well. So we currently have almost everything we need for the equation of this circle. But to describe a circle to someone, not only do you need to tell them the center location from which all points are equidistant, but you also need to know the radius, don't you? So let's find that radius. There's a couple of ways to do that. Can you think of one? Right, so the radius is the point from the center, which we've just discovered to be 2, 2, to any of these points on the diameter of the circle here. So the point could be 0, 1 that we use, or 4, 3, and we could simply get the distance between those points. Another thing you could do is find the distance of the diameter, so using the two original points, calculate the distance of the diameter segment, and then do what with it? That's right, cut it in half, because the radius is half the diameter. So whichever of those you feel comfortable doing, feel free. I think when I did this problem, I chose to do the distance between, I just did the radius. So I did the distance between the center and the point, let's say 0, 1. So let's use our distance formula here to find ourselves the radius. So to find my radius of the circle, I did the distance formula. Remember the distance formula? Can you write it yourself? What was it? That's right, the square root of x2 minus x1 squared plus parentheses y2 minus y1 squared, all under the square root. So plugging in what we have here, take a few moments, pause the video, feel free to do that yourself. I'm going to be using the point 0, 1 and the point 2, 2, because those are the points of the center and a point on the circle. And so if I can find the distance between the center and any point on the circle, that must be my radius. When you do that, come back and see how you did compared to what I got. So I ended up doing that and got, when you subtract your x values, 4 minus 2 gives you, not 4, but rather 2 minus 0 gives you 2, and you square it. Then you do 2 minus 1, and you get 1, and you square it. 2 squared is 4, and 1 squared is 1. So 4 plus 1 gives you the square root of 5. So we now have that our radius, is the square root of 5, which means a little more than the square root of 4, a little more than 2 units away. And you can tell that makes sense because in this picture, this was a distance of 2, this was a distance of 1. So if you were looking at a right triangle, for example, you're expecting that longest side, the hypotenuse of a right triangle, to be the longest side. So it is bigger than 2, so that makes a lot of sense. So now that you found your radius, you can plug it in. And when you do that, if you take the square root of 5 and you square it, because it's r squared in the equation, what should I really be getting here? That's right, just 5. So my final equation here should have been in standard form, parentheses x minus 2 squared plus parentheses y minus 2 squared, all equal to 5. Not the square root of 5, but the square root of 5 got squared. So if you need to write that out for yourself in your notes, I squared the square root of 5, and that's how I got 5. All right, so we did an example that was a little harder than the first example because this time we had to actually find the center by using the midpoint formula between 2 points on the diameter, and we had to find the radius by using the distance formula carefully. All right, so let's take a look at another possibility in your practice problems that you might encounter. And that would be if we give you the actual graph of the circle. So in example 3, we've given you the graph, but we've labeled a couple points. Again, this time we've been quite nice. It's very similar to the last example because the 2 points we've given you, they appear to be on the diameter of the circle. What do I mean by that? If you connect the 2 points that we've given you, let me grab a color you can actually see here. Let's do blue. If you connect the 2 points that we've given you, it does in fact appear to be the endpoints on the diameter again. Okay, so they've given you endpoints on the diameter, which is very helpful. And let me go ahead and label what those points are. The first point appears to be at 0, 1. They've just blown up this graph a little bit for us. And the other point appears to be at the x value of 2 and the y value of 3. So I understand what I'm dealing with now. I have 2 points, again, that are endpoints on the diameter. They're asking me to find the center, which we did last time, the radius, which we did last time, and finally the equation of the circle in standard form. So now this problem is identical to the previous problem. So again, feel free to pause the video and try it yourself. So what did we do last time when finding these pieces of information? Well, to find the center, which formula did we need to use? The center is going to be somewhere in the middle there, right? So that would be the midpoint between those 2 points in the diameter of the circle. So the midpoint formula, again, took the average of my x's and the average of my y's. What is the average of my x's here? 2 plus 0 is 2 cut in half. So the average x value is 2 over 2, which is really 1. The average y value would be 3 plus 1, which is 4 cut in half. But 4 divided by 2 is really 2. So my center, my HK, if you will, is the location of 1, 2. And check that out. That actually makes a lot of sense if you look at our graph. When x is 1, when y is 2, that does in fact appear to be our center. So we have our center at 1, 2. So we can answer that part of the question. Good job. What about the radius? What do we do to find the radius of the circle? That's right, we would need the distance formula here. So let's do that. For my radius, we use our distance formula, where distance was, what was it? It's the square root of x2 minus x1. So you need to pick your 2 points that you're finding the distance between. You got to make a choice here. Typically, I choose the center and a point on the diameter of the circle, or any point on the circle for that matter. Maybe you choose 0, 1. Maybe you choose 2, 3. You can pick which 2 points you're going to find the distance between. I'm going to choose these 2 points, 1, 2, and 0, 1. So then I take x2 minus x1. 1 minus 0 is just 1, and it gets squared. Then I take y2 minus y1, so 2 minus 1. 2 minus 1 is just 1, and I square it. Well, squaring the 1s, that's boring. It's just 1, and I end up with 1 plus 1 under the square root. And 1 plus 1, we both know, is just the square root of 2 underneath there. So we now have our distance between the circle and any point on the circle. Sorry, the center of the circle and any point on the circle. It's a square root of 2, so roughly 1.41 units away. So we found that the radius is in fact the square root of 2. And with that information, can we now answer the question about the equation of this circle? So the equation that describes the trajectory of this circular pathway. Well, yeah, it would just be x minus h squared, so x minus 1, good job, squared, plus y minus k squared, where k is 2, so y minus 2 squared, equals my radius squared. So what did you get on this side of the equation? If you take the square root of 2 and you square it, that's right, you get 2. So did you get, as your final answer when you pause the video on your own, x minus 1 squared plus y minus 2 squared equals 2? If so, great job. If not, try to find where you made your mistake, because we usually repeat those. Okay, remember, that's the circle formula in standard form. And there is the possibility that we could have FOILed out the x minus 1 terms, the y minus 2 terms, collect all like terms on one side. That would be called general form. And in the next example, we're going to see how we can recognize that that's really still a circle and work the other direction by completing the square. Let's take a look. So how do we go from that general form to our standard form, which is easier for graphing? Well, to begin, we need to actually know how to recognize a circle as a circle. Now in this class, we don't go much higher than circles. We get to parabolas, we get to circles, but in other classes, you typically will see other types of what we call conic sections, which are very similar in equations to circles, but just a little bit different. So we have to become really experts at recognizing equations and what type of trajectory they describe. So for example, we notice now that when we have x minus h squared plus y minus k squared equals r squared, that's the standard form of a circle. So we're going to be experts at recognizing that. But what else should we now recognize? We should also recognize that if we have an x squared term and a y squared term being added together, where the coefficients are the same. So the coefficient of x squared is 1, the coefficient of y squared is 1. This will also be a circle. So they're both squared, they're added together, and they have the same coefficient. That's telling you this is a circle, but it's in general form at the moment. So for example, consider the equation x squared plus y squared minus 4x plus 6y plus 4 equals to a number 0 in this case. As soon as I see that x and y are both being squared with the same coefficients and they're added together, this is a circle. So what do I do in order to rewrite it in standard form? The first step, move the constant to the other side. So that's what we've done here. We've taken that positive 4 and we've subtracted it on both sides. The reason we've done that is because we want to declutter the left side of the equation in our attempt to now complete the square 2 times. So how do we begin completing the square? Well, we're going to do it twice for both the x variables and the y variables. So we put the x variables together, x squared minus 4x, so like these terms together, we stick them in like a parenthesis. Similarly, we put our y terms together, so like y squared and positive 6y, those go over here. And because the terms were added together, the x squared and the y squared terms were added together, we do keep this positive sign in between them. And finally, we begin the completing the square process that we've studied in previous videos. How did we do that? Well, we took half of b and we squared it, right? What is half of negative 4? Negative 2. Take that negative 2 value and square it, and you get positive 4. That's the magical number that you have to add to both sides of the equation. So if you add a positive 4 on the left, you have to add a positive 4 on the right as well. Similarly, to complete the square for y squared plus 6y, you take half of b, which is 6. Well, half of 6 is 3. So you take half of 6, which is 3, and you square it, getting 9. So 9 is the magical number that you'd have to add to both sides. Now, if you need further review with completing the square, feel free to contact me, and I will get you some more resources to practice that. You can also come to my office, and there's some nice visualizations I have for you if you ever want to play with different blocks and building blocks and see it happen in real life. Okay, so here we go. Once we have completed the square, what's the point of that? The point was to rewrite the equation into standard form, where we have a binomial like x minus something squared. So do we have that now? Well, yeah, because we know how to factor, don't we? We can take the trinomial x squared minus 4x plus 4 and recognize that that's really x minus 2 times x minus 2. Again, if you need factoring resources to review, let me know as well. Well, the cool thing about completing the square, if you remember, was once you factor, the two factors are identical, aren't they? So if you have something times itself, can't we just say that that's base? That base is really being raised to the second power. So that's what we have here. We have x minus 2 squared, and we have y plus 3 squared. You can check that one out on your own. So now what do we have? We've found the equation of our circle in standard form. X minus h squared plus y minus k squared equals r squared. The whole point of doing that is that it makes it easier for graphing. Now you can recognize what your center is and what your radius is. Go ahead and tell me, what do you think the center is? Write it down for yourself. That's right. Did you get 2, negative 3? If you got the signs wrong, remember it's always x minus, the opposite of h, and then y minus, the opposite of k. What about your radius? Did you say 9 or 81? I hope not. Remember, this is actually r squared. So what is our radius then? It's the square root of 9. You're right, it is just 3. And that would allow someone to draw a sketch of the circle quickly. They plot the center and they go 3 in every direction. Okay, let's have you try one more example where you practice this process of completing the square to write your equation in standard form. In example 4, it tells us to do just that. We're asked to find the center, the radius, and the intercepts of this circle. Now again, in future math classes, we won't tell you it's a circle. You'll have to recognize it. How do you know it's a circle here? You know it's a circle because both x and y are being squared. What else? They're being added together. What else? They have the same coefficients. If all 3 of those things happen, this is a circle. It just happens to be currently in what we call general form. It's not as helpful for graphing, but it is the general form of a circle. So how did we go about the process of rewriting it into standard form so that we could read off the center and the radius quickly? We completed the square. Good job. So feel free to pause the video and try it on your own, or go back to the previous example to get a feel for what we did. Let's see how you did. First step, did you move your constant to the other side? So negative 60 became positive 60. And then we collected the x variables together, so like x squared minus 4x, and we left some space next to it. Good. Then we remember we're adding the terms together, so we put a plus sign there. And we put our y terms now, our y squared minus our 4y, and we left some space. Okay, what next in completing the square process? What's next? Yep, that's next. We want to take our b and cut it in half. So we take our negative 4. In both cases, they happen to be the same, so it's kind of a boring problem that way. But if you take negative 4 and you cut it in half, negative 4 cut in half, then we square it. That's b over 2 squared. That's the process for completing the square. We get negative 2 to the second power. But remember, a negative times a negative is a positive. So we're really adding 4 into this trinomial to make it a perfect square trinomial, which factors nicely. But if we add 4 on the left, we also add 4 on the right. And because the number is identical for b in the y parentheses, we get the same thing there, don't we? We also get plus 4 plus 4. So that one's a little bit boring. Typically, those are different, so you have more work to do. Now, next up, we factor, and we recognize that we're almost in standard form. So 60 plus 4, that's really 68, right? And on the left side, when we factor, we get x minus what? Yep, x minus 2 times x minus 2, or x minus 2 squared, and also y minus 2 squared. Check that for yourself. If you're not really comfortable factoring and you haven't done it in a while, make sure you understand the process of the factoring that I'm doing quickly here. Well, now we have the equation of this circle in standard form. Can we figure out from there what our center is and what our radius is? What do we have? That's right, our center is 2, 2. Because this is my h and this is my k, but in the equation it's always the opposite of h and the opposite of k. What about my radius? That's right, it would be the square root of 68. Now, could you break that apart? Could you simplify? You're always welcome to simplify as far as possible, but it's not actually necessary for this question. Okay. So it's a little bit bigger than the square root of 64, a little bit bigger than 8. Okay, what about intercepts? We haven't really talked much about intercepts in this video, but anytime you're graphing a line, a curve, a circle, any type of graph, it is always an expectation of the audience or of the textbook, if you will, or the homework, the practice, the test, whatever it is, that you know how to find the intercepts of that graph. That is an expectation we have for all students who have successfully taken an algebra class. So what do we mean by intercepts again? Well, we mean our x-intercepts and our y-intercepts. So by x-intercepts, those are the points on the x-axis, which meant that our y values equal 0. So if you were to let y equal 0 in this situation, notice what would happen. At the original equation, you'd have y squared going away and negative 4y going away, meaning you'd be left with just x squared minus 4x minus 60 is equal to 0. Similarly, if you wanted to find your y-intercepts, you would need to let your x values equal 0. And if you let your x values equal 0, you would be left with y squared minus 4y minus 60 equals 0. And you can tell these equations are pretty much the same, with just different variables. So at this point, you would either use quadratic formula, completing the square, or you would use the factoring method if possible. So I'll let you try those on your own. For practice, they're going to give you basically the same solutions because the numbers are the same there. But if you want to check for sure, check out that Desmos link provided at the bottom of the screen on your notes, and you'll be able to actually make sure you have the right answers there. But for the sake of time, I'm going to stop there since that wasn't the purpose of this video. Okay, so for today, just to recap what we've talked about, we've mentioned we know when to recognize that we have a circle when both x and y are squared with the same leading coefficients and they're added together. We know how to write it in standard form, with our h and our k telling us the center and the r telling us the radius. And we know how to recognize general form and work backwards by completing the square to be able to graph it and know the components of the circle. All right, well, it's up to you now. I hope you practice and you try your best. And if you have any questions, you're always welcome to contact me. Remember, math is not a spectator sport. I'll see you next time.